All right. Happy Monday, everybody. Uh, week 3, time is ticking right along. All right. So today we will take a look at data wrangling. So let's see. So on Friday, we talked about numeric summaries, calculating things like the mean and the standard deviation, what those things mean, stuff like that. And today we will, and I showed you a few operations like for the penguins data, we, uh, filtered down to a certain species, and then we pulled out like the body mass and stuff like that. And there's more efficient ways to do stuff using the data wrangling tools that are part of the tidyverse. Okay, so again, this class I'm very much heavily relying on the tidyverse, which in my opinion is excellent, and I know like we're using R, and sometimes students are like, well, why not Python? And I do like Python, okay? Because the class right before this is the Python class that I teach. So I do like Python a lot. But I think as far as like learning Python and learning the tidyverse, the learning curve on Python is, in my opinion, more steep than the learning curve on tidyverse. So like the tidyverse, you can just kind of focus on the data manipulation operations. Once you get a handle on understanding the tidyverse, those things will actually translate pretty quickly over to Python, either pandas or polars. There's kind of a lot of kind of similar operations and similar thinking that you can kind of learn the Python syntax and all of that, and then you'll have to learn the pandas and the polars syntax there. But if you have a good understanding of how data wrangling is handled in tidyverse, that will translate over quite well. Okay, so a lot of this is adapted from a textbook called R for Data Science. You can search for this on the internet, and you can read it for free in your browser. Okay, again, you can also pay for the physical textbook, but you can read it for free in the data browser. Okay, so the tidyverse, we're doing stuff in the tidyverse. We've seen some stuff with ggplot2 for making our data visualizations. And then within the tidyverse, the functions that handle the data wrangling is handled by a package called dplyr. Okay, and there is a cheat sheet that kind of shows what a lot of these operations do. Let me see if I can pick this up. So yeah, I don't know, it does kind of like, you have these rectangles, this represents your data, and it's like if you want to do this with these cases and things, you can do these different operations. But anyway, it's handy. Okay, so we'll load up our data. We'll load up our package, tidyverse, and then we're gonna load our data. Okay, and the data is titled Star Wars. This is an older data set. I don't know if we have how many Star Wars fans there are, but this was created kind of like right after Disney bought the Star Wars franchise, and they just released The Force Awakens. Is that the 7th movie? Is that episode 7? Okay. So anyway, there's been episode 8, there's episode 9, there's spin-offs, there's TV series, there's all kinds of stuff. And so an updated thing would have like many more characters, okay? But what this is this is a data set of all of the named characters that exist in the Star Wars universe from episode 1 through episode 7 only. It's, again, older data set. So kind of like original trilogy. And so I'm going to call data Star Wars. That loads up our data. And then you can kind of get like a preview of like what kind of stuff is in there. And so if you do glimpse Star Wars, it says there's 87 named characters. Okay, the first one is Luke Skywalker with a height of, I guess this is centimeters and kilograms, so 172 centimeters, 77 kilograms. I guess in the Star Wars universe they use metric system, I don't know. And then, what language do they, I shouldn't reveal too many of my cards here. What language do they speak? Yeah. Eric, I thought it was Galactic Basic, right? That's like
There are different ones.
Okay.
Arabash is the written one.
Okay. All right. Yes. All right. So you've got me beat there. All right. I'm not like a huge. Okay. Anyway, so we have this birth year. Birth year in the Star Wars universe is what, battle years before the Battle of Yavin, and we're using 365-day Earth years apparently ish. But okay, yeah, and Battle of Yavin is when the first Death Star blows up. Sorry, spoilers. And anyway, that's what we have. And for a planet that's supposed to be in the backwaters, there's a lot of important characters from Tatooine. So we have this, and this is kind of the stuff we have. This is kind of a preview, and you can see we've got the different kind of data types. Character means it's like text information, integers, and doubles and stuff. Integers are basically whole numbers, and doubles are numbers that can contain decimals. Okay. All right. So anyway, as far as dplyr goes, there's a bunch of going to be functions and verbs. Each of these functions perform a different task, but the functions all kind of have a common data structure, or a common operational structure. The first argument is always going to be a data frame. Okay. And the second is going to be like what columns it should do the operation on, or what arguments, what options you want. And then the output of the function is always going to be a new data frame. And each function basically does only one thing. So what you're going to end up doing is you're going to be chaining these functions all together, because the input's always a data frame and the output's always going to be a data frame. So it's going to be kind of like start with the original data frame, do this operation, you get an output. Then take that output, do another operation, you get a new output. Then take that output, get a new thing, and do another operation, so on and so forth. Okay. And what we're going to do is we're going to use the pipe. Okay. And I've talked about the pipe already. We've seen it as far as like doing starting with our data and filtering it to like a certain species of penguin or whatever, and then piping that into ggplot. We're going to really be using the pipe a lot. Okay. And again, there's kind of two versions of the pipe supported in R. You have the base pipe, and then you have this is the older pipe that existed before it got integrated into base Python. And you can hit Command-Shift-M or Control-Shift-M on your keyboard to insert the pipe. Okay. So when you use pipes, this is what it's going to look like. So if you didn't have pipes, this is kind of what you'd have to do. You have function, you have your original data, you have your options. The result of function 1 we might call temporary data 1. Then we do function 2 applied to temporary data 1, and we get we get temporary data 2. And then we might do function 3 on temporary data 2, and we get our final data. Okay. And there's kind of this is kind of annoying having to do this, because if you change something here or whatever, anyway, so with pipes, you don't have to worry about having these temporary kind of data frames in between where you have to worry about like, oh, it's very easy to get the thing wrong and say, oh, if you have a typo and you have temporary data 1 here instead of temporary data 2, things will break. So with the pipe, you just say, all right, take the original data, then do function 1 with these options, then take whatever that output is and put it into function 2, and then do functions 2, and then do function 3, right? So rather than having to do this, because again, the first argument of all of our dplyr functions is a data set, okay? But with the pipe, it's implicitly taking the output of the previous thing and then putting it into as the first argument for the next thing. Okay, so this is how we're going to see it. And we just say original data, then function 1, then function 2, then function 3. Okay. All right, so the first thing we're going to do is we're going to kind of work with rows. These are our row-wise verbs. We have filter, we have arrange, we have distinct. We've seen filter already, but I'll show you a few more examples. Okay, so if we look at the Star Wars data set, I can say filter and keep only things that are droids, okay? And we have C-3PO, R2-D2, these other droids, other robot entities in the Star Wars universe here, okay? You can put in multiple conditions. So I can say I want sex equals male, species equals human, all right? And so these are all the human males. So we have Luke Skywalker, Darth Vader, Owen, and Biggs, and okay, anyway. It's interesting. We have Anakin and Darth Vader as two separate entries in here. But I guess there is a, like, without the robot suit and with the, I don't know. Okay. All right. So one thing is that when you use filter or any of the dplyr verbs, it doesn't modify anything. It doesn't actually save anything. So this just outputs to the screen, okay? If you want to make use of this table later, you have to assign it, okay? And so here, let's say I want to find all of the females that are not human, okay? So I can do species not equal to human, okay? But if I want to make use of this later, I have to assign it, okay? I use this, the little arrow thing to assign it, okay? And then I can reference that resulting table or a data frame. And so this would be Star Wars female aliens. I don't know, alien, maybe that's not the right term to use in this. Everybody, aliens implies that there's like a home and people who aren't from the, okay, I should say non-humans. Okay. And actually, I don't know who these characters are because I don't know. Okay. But anyway, we have that. All right. If you want to kind of check if one is one or the other, use percent in percent, okay? So if we want to say species human or droid, you do species in percent, and then you list off the things that you want. So this would be humans or droids. And so we get Luke Skywalker or C-3PO and C-3PO and things like that because we have humans or droids. Okay, you'll notice when it prints it out, like it only prints part of the table and it just says, hey, there's 5 more variables that we didn't get to include, like homeworld, species, the films, vehicles, and starships and stuff. Okay. Some common mistakes that happen when you use filter is if you're, oh, and I made the mistake here. Okay, but you need to have, you have to use double equals. And here I have a single equal. This was, so I made the mistake, sorry. Make sure there's 2 equal signs there, okay? I have it correct here, okay? But if you only do 1 equal sign, you're gonna get an error. So 1 equal sign leads to error, and this needs to be 2 equal signs, sorry. Mistake. And then as far as or goes, you can't do this. You can't do species equals human or droid. That this will actually end up selecting everything because of the way R handles the or operator and things like that. So this is not going to work. You want to use the in. This is the preferred way, species in human or droid, okay? Or you can do filter species equals human or species equal droid, okay? So that's acceptable, right? And this form is better, like, I guess this would be the only way to do it if you wanted to do species is human or, I don't know, homeworld planet is Tatooine or something like that, okay? And then you'll get anybody who's from Tatooine or anybody who's a human or something like that, okay? Okay, so we have a filter to kind of just filter down which rows we want. Arrange will sort them, okay? So you can say sort them by height and mass, and this will go from least to greatest is the default. And so the shortest height, we have Yoda and and on these other people, okay, and their mass, and basically sorts on height first, and if there's a tie, it'll use the next variable to kind of break the tie, okay. And so we have that. If you want things in descending order, you can do this, descending order by birth year. And so we have Yoda born in year 896. And this is based on some not a throwaway line, but it's like, I think in Empire Strikes Back, there's a conversation Yoda has with Luke where Yoda's like, when you're 900 years old, you're not going to look as good as I am. And they presume the Empire Strikes Back takes place 4 years after. Okay, so anyway, and they're like working 4 years after the Battle of Yavin, and they say, okay, so they're assuming Yoda is exactly 900 years old in that scene, which there should have been a big birthday celebration, but I don't know. Okay, anyway, we have this. Jabba the Hutt is 600 years old, I guess, was born exactly 600 years, and Chewbacca, I don't know how they figure these things out, but anyway, that's what we have. Chewbacca doesn't get this respect he deserves for being 200. Okay. And then you have distinct. So distinct is if there's duplicates, it gets rid of duplicates. And then there weren't any duplicates. Okay. But you can kind of select one column, and you can say distinct, and this will be all of the unique values. Okay. And apparently there's 38 unique species that are in the data set. Okay, again, a little bit outdated. And then you can also provide multiple columns, and it will find unique combinations. So I said distinct, sex, and gender. I was just kind of curious, like what we have represented in the Star Wars universe. Okay, and so you have males that are masculine, you have non-sex that are masculine, you have females that are feminine, you have hermaphroditic masculine, you have unknown, and then we have none and feminine. And so you might be curious, like what some of these kind of correspond to, and distinct kind of generally just keeps the columns that you selected. And so you can say distinct dot keep all. So I did sex and gender, and dot keep all equals true. And this will only keep basically one entry, just the first entry that it encounters as it's reading from the top of the table down, okay, for each of these instances. So as far as male masculine, Luke Skywalker was the first, okay? C-3PO is a droid, so has no sex, but is personified as a masculine character. And it, so is R2-D2 and so on. Okay, so Leia is female and feminine. Jabba the Hutt, I didn't know, apparently, is presented masculine, but I guess biologically in the Star Wars universe. And then we have unknowns. And then I didn't realize there was a droid that is feminine presenting, and this is R4P17. That was Obi-Wan's astromech droid in his little in the prequels. Yeah. Okay. Yes. Question.
So if you do like the distinct for sex and gender, or like just for an example, let's say one of those distinctions has more than the other one, how would that?
Yeah. So right, like in the Star Wars, there's a whole bunch of male characters, male masculine characters, and all it does when you do distinct and keep all, it just keeps the first entry that it encounters as it's reading through the table. So like Darth Vader and Han Solo, these are all male masculine characters, but they are not included in this table because it just keeps the first entry that it encountered. Yeah. So you're definitely losing a lot of information when you do distinct, okay? But I mean, that kind of makes sense, right? You're just saying, I only want unique entries, and so you're just going to get one. But then you might be like, oh, I didn't know this was, I was like, oh, what is this? And then And I was like, oh, okay. So, this will kind of give you like, oh, here's the entry that we found, or the first entry that we found there. Okay. All right, we have, have I given you any view quiz answers yet? No, not yet. Okay. First answer today is D. D as in dog. D as in dog. Okay, we're going to look at a different data set here when we're for our columns data, just because when we're dealing with columns, we often want to do some numeric operations and stuff. And so for this one, I'm loading up this data set called NYC Flights 23. This is looking in the year 2023, all of the flights coming in and out of New York City. Okay, and so there's 3 airports in New York City. There's JFK, LaGuardia, and Newark. Okay, Newark's technically in New Jersey, but it services basically the New York City metro area. And so those are the 3 airports, and basically for the year 2023, they just recorded all of the flights coming in and out of New York. And so there's a lot, 435,000, okay? 435,000, and there's different columns, the year, the month, the day, the departure time. The time is written kind of like weird here. They're written as integers, but this is like 2038 would be like, what is that, 8:38 p.m., like on the 24-hour clock, okay? But it's weird, right? Because even though they're represented as integers here, you can't just take the difference, right? Because if let's say it's 8:48 and the next flight is 9 o'clock, okay, and you want to take a time difference between 8:48 and 9 p.m., that's 12 minutes, okay? But it represented this way, it would be 2038 and 2100. And if you did a straight mathematical operation there, 2100 minus 2038 would be 62, okay? And that's obviously wrong, okay? So, or what did I say, 2030? Oh, 2038 is 22 minutes from 9 p.m. But anyway, so you have to be careful with some of these things, okay? But anyway, we have departure time, scheduled departure time, the departure delay, the arrival time. I think departure delay is written in minutes, that it was delayed from when it was actually supposed to and stuff like that. You have the carrier and the flight and the tail number for each airplane, origin and destination. So I think all of the origins or destinations will always have either EWR for Newark, JFK, and LGA for LaGuardia, okay? And then you have airtime, distance, hour, minute, time, hour. So all of this stuff, and this is just kind of like what some of the tables look, first few rows. Okay, so we'll start with some of these things. So if you just want to select some of these columns, right? So there's 19 columns here. We can only see 8 of them here, and there's 11 more. You can select, and this will basically choose. You can also use it to kind of rename your columns. So here I just say, hey, I want to select year, month, day, departure time, and arrival time. And we have basically these things. We have these helper functions when it comes to selecting, and this can be helpful, especially if you have like a really big table with a whole bunch of columns. You might want to just select like some of these columns, and so this can be helpful. You have things like starts with, or ends with, or contains, okay? You're not familiar with regular expressions, I don't think, but there's also a powerful tool called regular expressions, and you can use those to select your columns if needed. We're not going to cover that in this class, but it does exist. You can also say, hey, pick any of these columns, and usually if you say like select a column and it doesn't exist, then dplyr, the tidyverse will give you an error. But if you say any of, and it can't find column B or something, it's not going to error out. It'll just kind of keep going, okay? Everything will select all of the columns and maybe all of the remaining columns if you select things. If you have columns named like X1, X2, X3, X4, or things like that, often in like some kind of, if you will, like an automated system, like a factory, and it outputs tables and stuff. Sometimes it looks like this, and that can be helpful. And then you have one over a named vector. So here's just kind of an example. We're going to say select all of the columns. If you put a minus sign, it won't select those. So we're going to say contains time. And so basically it selects all of the columns that don't have the word time. So these are the things. So we had like the other columns were things like departure time, scheduled departure time, arrival time, scheduled arrival time, air time. Those things are not selected because they contain the word time. Okay. We can say take flights and select the columns that start with departure or start with arrival, and everything else. And so this will kind of reorder the columns so that the departure columns and the arrival columns appear first, and then all the other columns arrive as well, appear as well in that order. So that the everything is useful as far as like picking everything remaining. When you select, you can also rename the columns if you want. So you can say, all right, we've got departure time, and I want to rename it to departure. Arrival time, and I just want to rename it to arrival, or R. Okay, and then everything else. And then so you have that, departure and arrival and things. So you have those columns. Okay. We have, sometimes you want to do computations. Okay. And so if you want to do a computation, you can use mutate. And what this will do is it's going to take whatever columns you select. So here, if we're going to departure delay and arrival delay, okay, it got cut off. But basically, it's going to take, for each entry, it's going to take that number. There's like an arrival delay number over here, and it's going to do the operation for that row, and it's going to do the operation for that row, and that row, and that row. So it's basically, for each row, it's going to do this operation. Okay, so it's going to create a new column with basically a new calculation for every single row in the table. Okay, so what's important is that the mutate, when you use mutate, it's going to create a new column with an entry for every single row. So you don't really want to use a function like mean with mutate, because what does mean do? Mean is a summary function, so it's going to it's going to calculate the mean, which is going to just be one number for the entire column, right? So if you say like, take the mean of this column, you just get one number, right? And then it's going to basically duplicate that entry for every single row. Probably not what you want, okay? When you do this, though, it always kind of creates the new columns at the end. So we can't even see the new columns that we created. So what you can do is there's an option called dot before. So we're saying, I want to create a new column gain and a new column speed miles per hour, which is going to be distance divided by airtime over 60, because this is like how many minutes the airtime was. Okay. And then we want to put it before all of the other columns. And so we're going to put that right here. And so to specify that, you use dot before. Okay. And the reason why we have to put a dot here is basically the tidyverse assumes you're not going to try to name a new column called dot before. Okay, because the format in this is like the name of the new column is equal to this, and so we're not going to. You might want to create a new column called before, okay, but it's assuming you're not going to name a new column called dot before, and so when it sees dot before, it says, oh, okay, we're going to place these columns in this location. Okay, so we're going to put it before everything else, and so now we get the new gain column, which again, we can't really see, but it's basically doing some operation there. With the thing, okay? If you want, you can, if you created a new column called gain, you could immediately use that column within the same mutate call and do like an operation based on that, okay? So I could take the gain, and then I can do gain divided by airtime over 60, so the number of hours of airtime, and we can get this column called gain per hour, which is kind of a weird thing, but this is just to illustrate that if you wanted to use this new column of values immediately, you can, okay? Is that good? All right. Sometimes we have, you want like a conditional operation. The printing got a little bit funny because of this greater than business here. But we have, you can have like these vectorized conditionals, okay? Which, based on this column, we have a condition, right? Is the arrival delay greater than 60? Okay, and if it's true, we're going to enter this into this column called long delay. Long delay will either contain entries of greater than 1 hour or this should say less than 1 hour, okay? And it didn't print out for whatever reason. That's why it looks funny. There's supposed to be a less than sign, okay? Or less than equal sign. And so that's what it does. The arrival delay column didn't get picked here, but isn't being displayed here, but it's basically adding this kind of thing. And so if there's a arrival delay greater than an hour or less than an hour, this is how it appears. Okay. So this is if else. You might have a more extensive thing, and we have an operation called case when. Okay. And case when is kind of just, if this is true, then this, and if not, check if this is true, then output this, and if that's not true, then check if this is true, and then output that, and then all else. The last one is like if none of the first ones are true, then the very last one is everything else greater than one. Output this. So we're going to check on arrival delay, and we're going to say, if arrival delay is less than or equal to 0, output earlier on time. If it's less than 30, you're going to say 0 to 30. If it's less than or equal to 120, do 31 through 120. And for everything else, do greater than 120. And so this is kind of like, it's just basically a more complicated version of this. The if else is just like a true versus false, and this is kind of like all of these different things. This is a handy little function, okay? Case when. And so you can kind of see these are some of the different things that we get. And so like entry 1, 4, and 5, those were long, and we can see those were all greater than an hour and stuff, okay? Transmute is like mutate, okay? But the default behavior of mutate is to create the new columns and put them at the end. We've been using dot before to kind of put them at the front. And transmute is basically create the new columns and only keep the columns that I put inside transmute, okay? So here we're going to keep tail number, and then we're going to keep gain and speed miles per hour, and those are the only columns that get kept. It's kind of like a combination between mutate and select. It's just like create these new columns and keep only these ones. Yeah, question? It does not, none of these things change any of the original data. So all of these things, it's only just outputting to the screen. If you want to change something or store it and be able to use it later, you have to use that assignment and assign it somewhere so that you can reference it later, okay? So yeah, all of these are just outputting to the screen, which maybe that's useful if you're just kind of checking for things, but if you want to make use of it later, you have to assign it somewhere. None of these change the original data, none of them. Okay. Relocate just moves columns around. If you do relocate, it will put columns to the very front. So you just say, hey, relocate departure time, arrival time. It's going to bring departure time and arrival time to the front, to the leftmost side, so you can kind of see it. Okay. It's kind of like using dot before, but if you're not doing any kind of mutate or anything like that, you can just take the column and rearrange them, relocate certain columns. Okay. You can also, if you wanted to have a specific location, you can relocate columns to say after arrival time or something like that. Okay, so here I want to put departure delay and arrival delay right after arrival time, and we can see that. Okay, and then if you want it at the end, if you want to take anything that contains the word delay and move them to the last column, you can do that dot after last column, and then you can see departure delay, arrival delay arrive at the end of the listing there. Okay, so here's just an example where we do a bunch of operations all together, where we're just kind of piping a bunch of things. So here we're going to do flights, then we're going to mutate, then we're going to do more mutations, but a transmute, and then we're going to rearrange our columns with relocate. So we have flights, we mutate to create our new columns of gain and speed, okay? And then we will transmute in that we're going to create a new column called date, okay? And this is using a function called make a date, okay? Make date, so our data here, we have a column for year, a column for month, and a column for day. And we understand this, but again, trying to do mathematical operations with this is actually really hard. Like if you have, say, how many days between January 1st and February 1st, like, how would you do that? Okay, that's actually really hard. Did I talk about this? Date. So we have as far as when we think about data, we have categorical variables and we have numeric variables. And did I tell you date is date a categorical or a numeric variable? So let me back up. Numeric variables tell you a quantity. You can do like, this is bigger and this is smaller and things like that. Categorical variables will tell you like a category, right? So the color of the candy is red or the color of the candy is blue, things like that, okay? So age would be numeric, height is numeric, weight is numeric. You can kind of say this person weighs 100 pounds, this person weighs 120 pounds, this person's 120 pounds heavier than the other person. 20 pounds heavier than the other person, okay? Okay, so, all right, let me back up. What about area code? Your phone number area code. Is that numeric or categorical? It's categorical, right? Because doesn't represent a number. If I say my area code is 818 and your area code is 310, we can't do math. And I can't say I have more area code than you, okay? That's a comparison that doesn't make sense, okay? All right, what about date? Is date numeric or categorical? Yeah, so the date is numeric, okay? It feels strange. The date is numeric because you can say, I was born January 10th, 19 whatever, and I was born, February this, 2000 this, okay? And you can do a mathematical comparison and say this person is this much older than the other person, right? You can do that, okay? The reason why date feels weird is the way we keep track of dates is this really weird thing that we call the calendar, okay? And we have like the month, that's categorical, or it's technically an ordinal variable, okay? So we have January and March and November, and those are not, you can do math comparisons, but only within the same year. Okay, so you can say, okay, November is 3 months after, I don't know, August. Okay, I'm trying to do the math here, and that works only if it's in the same year. But if it's across multiple years, like you can't do things, so it's kind of weird. Same with days of the week, also a weird thing. Yeah, so it's a little bit weird. So anyway, if you have the date information presented like this, it's really hard to work with, okay? But if you lubridate, make date, we'll take that date information and turn it into like dates that R understands. And if you have dates like this, R can do calculations. You can say January 1st, 2023, February 1st, 2023, and it can say, oh, the difference is 31 days, okay? And if it has February 1st and then what's March, okay, it'll say the difference is 28 days, right? Like, so it understands that, and you know, you can do it across years, and it will know exactly, like the internal calendar thing, it knows like, oh, this was a leap year and this was the whatever, okay? And so so you'll want to convert it into a date. Otherwise, like trying to do math with this is like really hard. Okay. So anyway, so we have that. We're creating a new column called date, and then we want to keep that column. We want to keep these other things like departure time, arrival time, and gain and speed miles per hour. And then we're gonna rearrange our columns so that date, carrier, all of this stuff shows up before departure time. And this is the result here. And we have whatever, this flight going from here to here. Okay. Let me give you your second answer. Is that what I'm doing? Okay, second answer is A. A as an apple. I'll go ahead and give you your third answer too. Okay, second answer is A. A as an apple. And your third answer is B. B as in bear. Okay. Okay, we have group by and summarize. Summarize is spelled two ways, with an S or a Z, okay? When I was learning, I learned it with the S. Later on, update it with Z, because that's how Americans spell it. But Hadley is from New Zealand, and he spells it with an S, and I learned it. So I often, like, just out of habit, I type with the S, but, you know, you'll see it with both ways. They're interchangeable, okay? They mean the same thing. And so basically, what this will do is you can select columns or whatever, and then you can do calculations. And this will calculate these summary statistics. So I can say, hey, what's the mean of height? What's the variance? What's the min? What's the max? There's also a function called count, and this will tell you how many entries there are. And so, and then all of these things have na.rm to kind of ignore missing values, because there are a lot of characters in the table that don't have height values recorded in there. Okay, so anyway, we get the mean, the variance, the min, the max, the count, and all of that, okay? And again, it's just taking that column height and it's calculating the mean. So you just get one entry and you just get one row here, okay? We have another function called group by, and this is really handy, okay? You can tell the tidyverse dplyr to go through the table and look at a categorical variable and create groups based on that. Okay, so we're going to take the species, and based on the categorical variable species, it's going to create different groups. Okay, and here, you know, when we do this, it doesn't look like much is happening. The only kind of indicator that something has happened is that we get this extra line up here that says groups is, there's 38 species, 38 groups based on species, okay? But if I take this group by species, and then I use summarize here, now it's going to calculate the mean of height and the standard deviation of height for each group, okay? So there was the Alina species, and apparently there was only one, so that had a mean of 79 and standard deviation there, okay? We have apparently 6 droids, and so the mean height for the droids is 131, and the standard deviation of height for droids is 49.1. Okay, we have a whole bunch of ones here. So remember, the result of this is a table or a data frame, so I can continue to apply more verbs, okay? So here I'm going to say, I'm going to basically take this same thing that I had before, and I'm going to say just filter. And I only want the rows where there was more than one, okay? And then I want to arrange it in descending order of how many entries there were, okay? So we have 35 humans that, and the mean height is 178 and the standard deviation of height is 12, okay? We have 6 droids and the mean height is 131 and the standard deviation is 49, okay? I guess unknown 4, we have 3 Gungans, and this is their mean height and standard deviation, and so on and so forth, okay? So here we are calculating the mean and standard deviation for each group, because we did group by species, and then we're going to do this. And this is like probably the most important combination that you can use, and will be like kind of going forward, and for your project and all of this, a lot of your work will require you to do this group by and summarize. You're going to say, hey, I want to calculate the average income for these different groups of people. Okay, I want to calculate the maximum this for these different groups in my data, and you're going to do group by and then do a summarize. Okay. You can do group by and mutate. Okay. And so there's something known as a z-score. Okay. And a z-score is a comparison between a value to its average, the group average, divided by the standard deviation. So it's kind of like, so if somebody is, like, let's say we're talking about heights. If somebody's average height, their z-score is 0. If somebody is above average in height, they will have a positive z-score. And if someone is shorter than average, they will have a negative z-score. Okay. We have a height, there's a standard deviation of height. So let's just say standard deviation is 3 inches. Okay. So let's talk about like adult men in the United States, average height, mean, maybe 5'9". Okay. And let's say standard deviation is 3 inches. Okay. So if somebody is 3 inches above average, so 72 inches, 6 feet tall, okay, they would have a z-score of +1. Okay. If somebody is 6'3" tall, they are 2 standard deviations above average, and they would have a z-score of +2. Okay. If somebody is like 1 inch above average, okay, their z-score would be 1/3. Okay, because they are 1/3 of a standard deviation. Each standard deviation is 3 inches, and if they're 1 inch above average, their z-score is 1/3, because they are 1/3 of a standard deviation above average. Okay, so anyway, the way you calculate your z-score is you take your value, subtract off the mean, okay, and then you divide by the size of the standard deviation. Okay, all right, so one thing I'm doing here is we're going to say filter to humans and droids, okay, get rid of or if species is unknown, okay, then we're going to group by species, and we're going to calculate the z-score. Okay, and this is doing it by group. So pay attention to the entry for C-3PO, okay, and look at Luke Skywalker. Okay, so C-3PO is 167 centimeters tall, and he has a positive z-score of 0.728. Okay, Luke Skywalker is 172, but he has a negative z-score. Okay, and that's because in the Star Wars universe, Luke Skywalker, compared to other humans, is shorter than average, so he has a negative z-score. C-3PO, compared to other droids, even though he's shorter than Luke Skywalker, compared to other droids, which include like R2-D2 and stuff like that, C-3PO is taller than average, so he has a positive z-score. Okay, so despite this person's height being objectively higher than this character's height, this person is below average compared to their group, and this character is above average compared to their group. And so this person has a negative z-score, and this one has a positive z-score. Okay, if I get rid of the group by, and I just did a comment out here, I just put a hash mark here, and so this just tells R to skip this line. Okay, so we're not grouping by. Now it's going to calculate the mean for everybody and the standard deviation for everybody. And so now Luke Skywalker is just barely above average, has a slightly positive z-score, okay? And C-3PO is slightly below average for everybody combined together. Yeah, question?
What's the is.na?
Is.na is basically if it's missing. If it's missing.
So does that like
So in this case, it will include it. So we're going to include 3 species: humans, droids, and unknown species in this case. Am I out of time? Yeah. Okay. Well, this is like slice, and so if you do a group by, this is also handy if you want to just pick out like the min or the max or like the beginning or the end of a group. So you can do like group by homeworld, and then I want to pick the tallest person from each planet. Okay, and you can do slice max and things like that. Okay, and this will figure it out for each group. Okay, we'll end here. Have a great rest of your day, and we'll see you Wednesday.